So we've been working out of this packet. We've been working on two things. One is writing expressions. So if we have a shape like, if I could draw, a shape like this, where we are given dimensions like 5x, 3x, radius of 2x, something like that. I want to know an expression for the length of this piece. How would I write that out? Well, it would be a combination of this dimension, and that radius, correct? So that would simply be 5x plus 3x plus 2x, which can be combined to make 10x. So that dimension there is 10x. If I wanted to know the dimension across here, there's two different ways I could express that. One way I could do it is in terms of x. In terms of x, what's that dimension going to be? Yeah, 2x and 2x makes that 4x. In terms of y, I have 4y minus y, which would make that 3y. Even though it's just a y, I think of it as a 1y, so it's 4y minus 1y is 3y. Just like sometimes you'll have an inch, it's really 1 inch. What's that for here? Yeah, you can say 1y and 2y. Yeah, y would be just 1y. You could think of it as. So yeah, 4 minus 1.
Instead 4y minus y plus 3y.
Y plus 2y would be 4y. Yeah, going backwards, yes. Yeah. So on this one, I want to know what's this dimension. What's an expression for that dimension? Well, if I knew this dimension, I could get to that. This dimension is going to be my 7x minus my 2x, which would be 5x. This would also have to be 5x then. So then this becomes 5x plus x, which would be 6x. Simple enough? Okay. Well, then we also worked with formulas. Might look something like this, where your taper is defined as taper per foot, big D minus little d over L divided by 12, where big D, little d, and L are all given in inches. The reason L is divided by 12 is so we can convert it to per foot. And let's say that this large dimension here, this large diameter, is 2 1/4 inches. Our small diameter is 1 3/8 inches. And our length here is 14 inches. To calculate this as a taper per foot, it's going to be 2 1/4 minus 1 3/8 over, now I'm going to put this in parentheses just because it's going to make it easier to enter it in my calculator. 14 divided by 12. So when I enter this in the calculator, I'm going to use parentheses. 2 1/4, I'm going to put it as 2.25, minus 1 3/8, I'll put it as 1.375. Your calculators have fractions on them, mine doesn't. So yours, you could enter it as a fraction if you wished. Divided by, then I'll put it in parentheses, 14 divided by 12. I get 0.75. What that is saying is there's 0.75 inches of taper per foot of length. So the diameter is changing by 0.75 or 3/4 of an inch per foot of length. Does that make sense? The only really tricky part to this is seeing where you have to put in the parentheses when you enter it in the calculator. Otherwise, if you don't see that, you can always just do the subtraction on top, get that number, do the division on bottom, get that number, and then punch them back in. The thing you run into is a lot of times you're going to end up with repeating decimals that are going to be ugly. There's going to be round off error if you write them down and punch them back in. You can use the answer key on your calculator to avoid some of it, so you can recycle the answer instead of having to type it back in. But the one warning I will give you is write down every digit that's on the screen if you're going to write it down and type it back in. Because if you round it off after 3 or 4 decimal places, it can be a significant round off error. Okay, so we've been working with these variables and we've been combining them a bit. I want to go through and do a little bit of a review of combining variables. So if I have something like x squared minus 3x plus 7, and I want to add that to 3x squared plus 8x minus 9. So some of your textbooks would show just drop the parentheses and combine what they call like terms. But as we've shown, this is really just, each of these is really just a 3-digit number written out in expanded form. Instead of having place values that are powers of 10, these have place values that are powers of x. So I can add these just like I would whole numbers, writing them out one on top of the other. So x squared minus 3x plus 7, lining up the 3x squared with the other x squared, the positive 8x with the negative 3x, and the negative 9 with the positive 7 from up above. And now we are just adding down the columns. So now we can combine 7 with negative 9 makes negative 2. Negative 3x with positive 8x makes positive 5x. And x squared and 3x squared make 4x squared. So we get 4x squared plus 5x minus 2. Addition isn't so bad working with the negatives. Remember, we pointed out that is one of the differences between our algebraic numbers and our whole numbers, or integers. In our regular numbers and our integers, either every digit is positive or every digit is negative. In our algebraic numbers, you can see each digit can be positive or negative on its own. So here the negative 3x is negative, but the other digits are positive. Here that's a negative 9, but the other digits are positive. And it can be a little bit tricky dealing with that. In addition, as I said here, it's not too bad. But when we switch over to subtraction, it can get really ugly. We might have 3x squared plus 7x minus 5 minus 7x squared minus 12x plus 9. So once again, we're going to write this out and line these up vertically. So I've got my 3x squared plus 7x minus 5. Now I'm going to put my x squareds under my x squareds. 7x squared goes under 3x squared. My x's under my x's, negative 12 under the 7x. And my 1's under my 1. So positive 9 goes under the negative 5. So now we are subtracting down each column. Negative 5 minus 9 is... There we go. Yeah, it becomes negative 5 plus a negative 9, so it's a negative 14. 7x minus a negative 12x. Well, 7 minus a negative 12 becomes 7 plus 12. So positive 19x. And 3 minus 7? Negative 4x squared. Not too terrible. We had things like this. Now we looked at two different ways of doing a problem like this. One was to write it out the long way and multiply. Just like you would any long multiplication. 5x squared times a negative 7x to the third. We multiply the counts. 5 times negative 7 is negative 35. Then we multiply the names. X squared times x to the third, x to the fifth. 5x squared times 3x to the fifth. Well, 5 times 3, 15. X squared times x to the fifth, x to the seventh. That's the real way of multiplying that out. That's the long way of multiplying it out. Most of us at some point have been shown a shortcut. They use the term distributing. Looks like this. You're just going to do 5x squared times 3x to the fifth. Well, 5 times 3 is 15. X squared times x to the fifth is x to the seventh. And then 5x squared times negative 7x to the third. 5 times negative 7 is negative 35. X squared times x to the third is x to the fifth. We get the same answer. This way is just a little bit shorter. It takes a little bit less space. But remember, this is just a shortcut. This here is the long way, the real way of multiplying that out. In your notes, I want you to try this one. Try that one in your notes, see what you come up with. So we're going to start out with the first parentheses. Anytime we see a parentheses, as we mentioned when we were doing order of operations, we should be thinking that we need to do something there first. And it's no different here. We see this first set of parentheses, we need to ask, is there anything that needs to be done inside those parentheses? And in this case, the answer is no. So the next question we should be asking is there anything that needs to be done to those parentheses? And in this case, that answer is yes. They're being multiplied by the 3x squared. So 3x squared times 8x to the third. Well, 3 times 8 is 24. X squared times x to the third is x to the fifth. Then 3x squared times negative 5x. 3 times negative 5, negative 15. X squared times x, x to the third. Now next we have the second set of parentheses. And again, we have to ask the same questions. Is there anything that needs to be done in those parentheses? And the answer, once again, is no. So our next question is there anything that needs to be done to those parentheses? And it's yes. They're multiplied by not 7x to the third, but negative 7x to the third. When we're dealing with algebraic numbers and polynomials, that minus sign, that subtraction, is really the sign of the number that comes after it. So it makes that a negative 7x to the third. So negative 7x to the third times 2x to the second. Negative 7 times 2 is negative 14. X to the third times x squared, x to the 3 plus 2 is 5. Negative 7x to the third times negative 6. Well, negative 7 times negative 6. Positive 42. Negative times negative is a positive. And there's nothing to multiply the x to the third. Are we done? Say no. What can we still do? Combine. We've got 24x to the fifth and negative 14x to the fifth. That makes what? 24 and a negative 14 make 10. When we're adding or subtracting, we keep the same name, so we don't change the power. It's still x to the fifth. Then we've got negative 15x to the third, positive 42x to the third. Negative 15, positive 42 becomes positive 27x to the third. Now notice I had to put the plus in here to link those two digits together, since that's a positive 27. So there it is. How many of you got 10x to the fifth plus 27x to the third? Okay, we maybe need to try one or two more of those. Let's do something like this. Try that one and you know it's quick. So when we look at this one, again, we should be drawn to the parentheses first. Is there anything we can do inside those parentheses? No, x to the fourth and x squared are different names, so we cannot combine those. So then we have to look at what's being done to the parentheses. They're being multiplied by a negative 3x squared. So we've got negative 3x squared times 5x to the fourth. Negative 3 times 5 is negative 15. X to the sixth. Negative 3 times negative 2 is positive 6. X to the fourth. Now we still have the 7x to the sixth up front. We've got minus 9x to the fourth and back. So now we're going to combine 7x to the sixth. And the negative 15x to the sixth makes positive 7, negative 15, makes a negative 8. Now we're adding or subtracting there, so we keep the same name, so that stays x to the sixth. And then here, positive 6 and negative 9 makes negative 3x to the fourth. How many of you had that one? Okay, do a little bit better. We can have multiple variables in those deals. We can have something like this. 9x to the eighth, y to the third, z times 7, x to the fifth, y to the fourth, z to the third. And the way we handle this is we work with the count first, and we work with each variable or each name separately. So 9 times 7 is 63. X to the 8th times x to the 5th. X to the 13th. We add the powers. 8 plus 5 is 13. Y to the 3rd times y to the 4th is y to the 7th. 3 plus 4 is 7. Now for z here, this is just z, so we think of that as z to the power of 1. So z times z to the third is z to the fourth. 1 plus 3 makes 4. We can run into bigger problems like this. When we go to do anything with this, we see once again we can't do anything in the parentheses. So we're going to multiply through or distribute the 7x to the third y squared. So 7 times 4 is 28. X to the third times x squared is x to the fifth. Y squared times y is y to the third. Think of that again as y to the 1. So 2 plus 1 makes 3. So now 7x to the third y squared times negative 5xy to the third. 7 times negative 5 is negative 35. X to the fourth. Y to the fifth. So there it is. We could divide the same way. We could have 28 x to the fifth, y to the third divided by 7 x to the third y squared. So just like we did with multiplication, we still combine the counts. We're going to divide the counts. 28 divided by 7 is 4. But now when we divide the variables, we do what with the powers? Subtract. X to the fifth divided by x to the third. 5 minus 3 is 2, so it's x squared. Y to the third divided by y squared. 3 minus 2 is 1, so yeah, y to the 1 or just y. So we have 42 x to the 8th, y to the 5th, z to the 4th, divided by 14 x to the 3rd, y to the 4th, z. So 42 divided by 14. Is 3. X to the 8th divided by x to the 3rd. 8 divided by 8 minus 3 is 5. Y to the 1 or just y. 5 minus 4 is 1. So y to the 1 or just y. Z to the 4th divided by z is z to the 3rd. Again, that's z to the 1. 4 minus 1 is 3. Just like we could distribute with multiplication, we can distribute with division. If I have 27 x to the 6th y squared minus 18 x to the 4th y to the 3rd plus 36 x squared y to the 4th divided by 9 x squared y squared. I can divide each term separately. So 27x to the 6th y squared divided by 9x squared y squared. 27 divided by 9 is 3. X to the 6th divided by x squared is x to the 6 minus 2 is 4. Y squared divided by y squared cancels out. It's nothing. So now I have negative 18 x to the 4th y to the 3rd. Negative 18 divided by 9. Negative 2. X to the 4th divided by x squared. 4 minus 2 is 2, so it's x squared. Y to the 3rd divided by y squared is just y. 3 minus 2 is 1, so y to the 1 or just y. Positive 36 x squared y to the 4th. 36 divided by 9. Positive 4. X squared divided by x squared. Cancels out. Y to the 4th divided by y squared. Y squared. And that is it. Well, kind of running out of time here, so I didn't get through the stuff. This is actually all review of stuff we did before. On the pages that this was all on, let me find it so we can go back and review it. In your book, started on page 333 and went up through page 343. It was exercise 13.2, 13.3, 13.4 and 13.5. Again, those were assigned about a week ago, but I'll throw them out there again for you to review.